So I want to ask kind of the question, get right into it. Is it even possible to build a defensible AI company in 2025 without owning data infra?
I think you're going to have some kind of data infra, right? I think the answer is no, it's not possible. But how much of a true advantage is that? And it depends on what you're calling an AI company as well. If you're talking about a model foundation company, one of our largest customers is one of the major model foundation companies. So I think that kind of says that it's a very important ingredient. Is it essential? I don't know. But I would say any company that's an AI company these days, meaning someone who consumes and uses it and gains a significant advantage in their market niche, it's intrinsic to your success. You have to track data. You have to govern the data. It's kind of like I've described it as a Maslow's hierarchy almost. Like you have to have that layer done before you can even achieve the next levels of influence through AI.
Yeah, I just push it even to a point that any AI product today, whether you're building it or buying it, will have an underlying data substrate associated with it. I think the change in what we're seeing with the data systems that are being built today, the complex and compound AI systems that are emerging, is that we have to have a way to be able to process and understand unstructured data. And that's an area that has been challenging for many folks up to this point. Certainly that's where the frontier of most of the models are continuing to improve in terms of data fidelity.
Yeah, George, you've seen many infra companies over the years, and as we mentioned, worked at a couple. Talk to us a little bit more about this. It's interesting you mentioned the unstructured thing. Why don't we take a little detour there and chat about that? Because, what does that really mean for app builders? I think when a lot of people think of unstructured data, they think the model handled that already. Like the unstructured data is in the model, right? So,
right.
What else is there to think about, and what are sort of what's the next generation of challenges there?
I think before we go into the app building side of things, I just want to get into a little bit more of the challenges of building models today, right? And we think about some of the challenges in terms of getting high quality models. On the pre-training itself, what's very clear is that you don't have this ability to build these high quality models, call it the next generation post GPT-4 style of models that are going to emerge without a fairly large quantum of data at scale. And that's not just about, call it the structured data that might be coming from a variety of sources. It's very clear that there's highly capable sources of unstructured data that's needing to be processed, particularly from a pre-training standpoint. I think the other area that I'm actually really fascinated by is just the whole notion of once the model is trained, the post-training, when you think about the instruction tuning that's necessary to be able to align a model, particularly when it comes to building and deploying enterprise scale applications, it's also a data problem, right? Particularly when you think about the use of reinforcement learning, the use of RLHF, the use of RLAIF. And so in all of these cases, I definitely see this sort of underpinning of how you manage your data pipeline, how you manage your data substrate effectively as kind of the success or failure of how you can deploy AI applications at scale. Some of that is in the hands of the model builders themselves, but honestly, quite a bit of it is going to be in the hands of enterprise developers that need to be able to be very versant in these variety of data sources to be able to align, tune, build, scale AI systems that happen to have an underlying foundation model associated with it, or more than just a foundation model.
Well, and you said isn't the data just in the model already? I think what's interesting is that that's almost like applying a very old view of data and how it's going to be used into this new world. I think what's interesting about data is not necessarily the facts that are in the data itself. Which it is actually, of course, very useful and needs to be grounded in those, but it's also the structure of the particular kind of data. So, looking at an example I always like to give is a legal contract versus reading prose. In a legal contract, I could have condition 1, 2, 3, 4, 5, and at the end I'll have a sentence. If this other condition is true, then none of these apply. I don't write prose this way, right? So the connectivity of information in a legal document is actually quite different and the structure is quite different than the way we would write a story, perhaps. So actually understanding that and making a model understand that and be able to interpret facts that are given to it is actually, in my mind, the thing that's very hard to do. So it's not just about the data, it's actually customizing the model, and you could call it reasoning, you can call it whatever you want, but customizing the model to be able to interpret those grounding facts in a way that's useful for an application is really the holy grail. So data pipelines, data processing are a major part of that. Then there's some aspect of how I either aligning the model or pre-training. I actually think pre-training is kind of a broken concept generally, and I say that as been in this field for a very long time. I think basically figuring out a way to make the model understand and interpret the type of data you're going to give it for the application you need is going to be the major points of innovation going forward.
Naveen, you should expand upon that little point on why you think pre-training is broken.
That's where I was going.
Yeah, sure, we can talk about that. I mean, pre-training was a great step because it's auto-regressive, meaning you don't need to label data. You just have the inherent ordering of language, of the words in the language, be the labeling in a sense. So you can derive a loss from that. So this was a kind of a shortcut to say, ooh, I have all this data, I have all this text sitting around. Now I can use that to train in basically a labeled paradigm framework I could use with unlabeled data. Great, and it is a very rich loss function. But the problem is, that's not really how, say, a biological entity learns. A biological entity actually, has maybe some kernel of what it thinks is how the world works, proposes a hypothesis, acts upon the hypothesis, and then reinforces good or bad outcomes. And so this is how we kind of make our way through the world. We don't just observe, gobs and gobs of data and then say, okay, now I understand how the world works. You actually have to act in it and feel the consequence of it. And that's something that's lacking today. So that's why I think pre-training is kind of broken. We put way too much emphasis on this. It's like, I just have data, I'm going to keep throwing it at it, I'm going to keep scaling. That's never going to work. I never thought that was going to lead to AGI. I mean, it was a step along the way, and I think it was a useful step for us to understand. But this is why we're seeing this idea of scaling laws kind of breaking now, is that you can't just keep throwing more data at it. Because, I mean, if we want to get into the weeds a little bit more, what these transformer models are really doing is building an estimation of conditional probability. So what they're saying is given X, Y, Z, what is the probability of the next token? And you can have latent variables and all kinds of things inside of that, but really you're building this conditional probability distribution. So if you keep throwing more realizations at it, you can estimate better. It's like now I have more points along my line to interpolate. But the space of language is larger than the number of stars in the universe. I can't effectively sample every possible English sentence that could be constructed and actually make that probability distribution much better. So I need to have some other way, some sort of a model of the world to actually understand what language is trying to describe.
So you would be arguing for the notion of labeling later in the value chain.
Yeah, I mean, again, labeling is kind of, I don't know, it's not the concept that's going to get us to AGI, to get us to agents, because it's again, observational learning. I think just kind of think back to how you might teach a child something. You label some samples, but they also have to experiment on their own and feel the consequences of those actions. So you're kind of guiding their formation of a mental model, but you're not fully describing it with labels.
Yeah, I think this is where it's fascinating because it's sort of an argument of how much should you structure the data going into the model, because you can see that when just as a consumer of the model and you structure your own data going into the model at the query at inference time, it dramatically affects the quality of your results.
Yeah. So
based on that, one would think, oh, well, I should be structuring the data, just work backwards in the pipeline, and that would be more effective or more efficient, right? But you're saying you sort of doubt that's necessary. It's not necessarily a linear progression in that.
That's right.
In that regard.
I think the way to use data, I see going forward, is actually either confirmatory or to refute a hypothesis. So if I have all these samples, and I'll call those groundings they're ground truth, right? I've observed something in the real world, and that's ground truth. So now if I have an internal model of how the world works, I can propose a hypothesis. I can now test that against my data points. That's what we should think of data. It's a sampling of the world. It's not the definition of the world. Right?
Well, there's a really good example of that even in the last, I would say, 2 years or so. The delta between GPT 3.5 and 4 was literally this idea that there's a reinforcement learning loop, and that improvement in the reinforcement learning loop was what improved the model itself to create the outcome of where 4 and all the models subsequent to went. So it is very clear, that Naveen's point that the reinforcement learning and improving and instruction tuning the models themselves is where we're going to see a lot of benefit coming up.
And so going down the road to the enterprise sort of challenge around all of this, and really feeding in kind of more the infrastructure component. Do you think we have the infrastructure that we need currently today to support enterprises in doing what they need to do with these models? What are the big failure modes right now that you're seeing, and where are the gaps in sort of the infra stack that we might need to think about?
So I generally think much of the tooling is here today, right? And I think the reason I believe that is I don't think this is a situation where we put everything into a single model and presume that the model is going to be able to do everything it needs to do to build the next generation of enterprise systems. I think the world is going to move much more towards compound AI, where you're going to use both the value of what you're getting out of the models today, which is a very thoughtful, reasoning-oriented probabilistic system, and bring that together with a lot of deterministic engines that are already available, right? You have calculations, you got aggregations, you've got, ML systems that have been around for quite a while. And I think there's this notion that, hey, we're just going to throw it all out to go build a Uber, call it transformer-based, single system that's going to be able to, answer everything. I don't think that's where it's all going to end up. It's very, very clear that the use of orchestration and agent-based capabilities today is about orchestrating many, many things in the enterprise for a compound AI system to emerge, not this sort of single monolithic answer.
Yeah, obviously, fully agree with that. I think what I would say is majorly lacking is actually efficiency and cost. It's still super expensive to do a lot of this, and I think if you can look at the history of computing, you can see that things were generally super expensive at the beginning of time. So I think we probably have the infrastructure to support the different explorations, sort of the delta from where we are today. I think we probably have that infrastructure largely built. So I would agree with George on this. But I think it's way too expensive and way too hard to manage still. And that's what we're doing at Databricks, I was doing it at Mosaic. We're trying to move up that stack and make it more turnkey, more accessible, more democratized. But at the same time, I think there's still fundamental innovations on hardware that aren't done. The fact that a GPU runs nearly 1,000 watts now is insane to me. We're still so far away from what we need as the proper computing substrate for AI.
Yeah, I think, there's a lot of tool builders in the Data Council community. So I think one of the subtexts that folks will be thinking of this week, at least I do, is sort of where are the gaps for the next generation of tools. And one pattern I've seen, I think it's a naive pattern, but a lot of founders tend to be copying infra patterns, tooling paradigms from ML and from classic data, and just willy-nilly copying them over into the AI world. It's oh, well, if we had monitoring here, we need monitoring here, and it looks the same. Oh, if we had routing here, oh, we need model routing now, it looks the same. And so there's kind of a very simplistic, sometimes, way that I think some engineers or some founders are doing this. And at first it sounded made more sense a couple years ago. We thought maybe that was sort of a valid mental model, but I'm really believing that less and less now. I'm curious if you have any thoughts on sort of what we're going headlong into now building that might not actually be supportive of the way this future stack actually looks in 2 or 3 years.
There are probably a few concepts that I think traverse most of these shifts that occurred in enterprise software. And maybe for this sort of AI wave that's in front of us, it's pretty clear to me that, there's still a need for an identity system somewhere in the middle of this, right? It's not going to be the same exact one that we've known up to this point for cloud, but it's going to be there.
Actually, there's more of a need for it, I think, as we start moving to agentic.
Totally.
Right? Yeah.
Right? There's a need for orchestration, right? And we're starting to see that particularly with agentic flows today.
Especially across like sort of disparate systems of, like you mentioned, deterministic, non-deterministic, et cetera, et cetera.
Yeah, if you're building a compound AI system, there's no way you can do that without some orchestration involved in the middle of it.
Yeah.
There's an absolute need for observability, right? There are a few of these areas that I just mentioned that you're gonna need to have, very deep infra, but it might not look like the last generation of observability, identity. Oh, by the way, the last one was integration, right? And so all four of these are at least present in every other stack before it. But it's just not those providers that are going to likely be the folks that are going to provide the observability, the orchestration, the integration, the identity in how compound AI systems emerge. So I'm very excited by that because I think there's like a room full of folks here that are actually thinking through that as we speak. And it's actually an area where I'm putting a lot of my time from an investment standpoint.
And since you've invested in so many companies, Databricks, Hugging Face, others.
I didn't do Hugging Face. I missed that one, but we did catch Databricks recently. I did Weights and Biases.
Weights and Biases.
That was
sorry, my mistake.
It's okay.
Weights and Biases. So, how have the battle lines changed, do you think, in terms of how do you perceive the world and the opportunity as an investor now and investing in this space? Like, what's the same, what's different? Like, how have things shifted?
Yeah, so I wasn't a VC by any professional capacity until, 5 years ago. I was a builder for most of my life. But going into the venture capital world, I took a bit of I have been building stuff, and so maybe I should think about what needs to be built. And so that's how I literally landed on Weights and Biases as my first investment at Insight. And that was because I just started to notice that, that MLOps tool chain was a bit broken, and particularly when it came to just the specifics around doing experiment tracking and parameter tuning and version controls. Those were areas that, there wasn't high quality tools. And really there was only two options at that moment that really emerged. One was MLflow, which of course Databricks is doing an incredible job with, and the other was Weights and Biases. And both of those really played out in the market then. If I kind of look at this next wave that's occurring, I think we're already pointing to some areas that, seem like investable companies, right? And maybe it's been announced that we led the Honey Hive round. A great example of just a natively agent LLM first observability experience, right? That's what Mohawk and Drew have built. And we were just very excited to follow on from your initial investment to join and lead the next round. I think those opportunities are pretty exciting right now. No surprise, I'll say it out loud, I'm looking for areas where this post-training focused effort on instruction tuning can really reimagine how models can align. So another area that makes sense. We were just delighted to join the Series J and co-lead the, call it 10 billion round that Naveen and Ali and team raised for Databricks. So there are opportunities both in early and in late stage, but anywhere there's, call it, incredible founders doing amazing things, try to find those opportunities and just go after them.
And Naveen, you're a founder yourself, and I'm just curious, I don't think I've ever heard the high-level sort of origin story of Mosaic ML. Like, what was it that possessed you to start a company at that time? And give us sort of what was your key insight that led you to build this infrastructure company that was acquired by Databricks?
Yeah, I mean, it's something that's been ongoing in my head for a very long time. I mean, my whole career, the first company I started was like kind of the first AI chip company in this whole space. And it's actually a similar motivation to Mosaic was, neural networks are actually a new computing paradigm. It's a new way to describe a computer, and potentially a computer that can do, when you describe a computer in this way, you can potentially do new and interesting things because of the sort of stochasticity of it or the probabilistic nature of it. And so that necessitates a new way to think about the infrastructure. You have to build a different kind of computer. I mean, you can use any physical system to compute, but you got to build the right architecture to make that thing efficient. So all of it's been about efficiency. And so what I recognized, actually maybe even 2018, I mean, that's when we saw the transformer come about, and scale started to become a thing. It was very hard to build scalable systems at that point. Also, once you build the sort of infrastructural software layers, actually making it do something efficiently was not only hard, but I think it was actually the barrier. The cost was kind of growing essentially super linearly, actually quadratically with the number of parameters. So that's a huge problem, right? If you want to actually scale things up, and this is when I thought scaling to more and more data was actually the right thing to do. It was the right thing to do at that point. Now we've come to a point where we've kind of saturated that. We need to move to the next thing. But at that time, it was like, well, what's the barrier to scale? Well, we need to build efficient systems. Okay, well, where can we find efficiency in the stack? And what I saw was that, Moore's Law is, let's say it's ticking along. In its heyday, Moore's Law was about 40% year on year. That's 2x every 2 years. So call it 30%, or maybe even 40% when you're talking about like packaging and things like this. If I want to do more than that, I can actually look at software and algorithmic efficiency. And that's where Mosaic came from. It was like, okay, if I can use the functionality of the hardware more effectively and make it work in a stable fashion with my algorithms that are actually doing the learning, I can actually get more than 40% per year. And actually, it turns out this is a sort of law that we posited in 2021, where we saw that these systems are actually getting on the order of 4x, so 400% more efficient year on year. So what that means is the amount of, I was doing it per dollar, not per compute flop or anything like that, but per dollar, how much it'll cost to build a model of a certain capability and serve that model will be 1/4 the cost in 1 year. So that's 10x Moore's Law. So you got 40% coming from hardware. Where's the rest come from, right? It's really algorithms. And we've seen that play out now for the last several years. Like, GPT-4o is much smaller than GPT-4 is. I mean, at least an order of magnitude, maybe even more. So, but it's better. It's a better model on pretty much every dimension. And so we're seeing that, yes, we're getting smarter with the way we present data to the model. We're getting smarter with the way we train it. We're getting smarter with the way we use our compute to get higher performance. And so all of that translates into cost. To me, I look at all of these systems as a three-dimensional service between cost, time, like time to train or time to serve, and performance, basically how good it is, how intelligent it is. And so how can we basically push that Pareto frontier, I guess you can say up and to the left, kind of make it more efficient.
Well, I want to touch on sort of how open source affects this world, because we have lots of open source developers in the Data Council community.
Yeah.
Is the future of this stack, is it open source and composable? Is it not? Is it proprietary and all owned by OpenAI? Like is OpenAI going to build all the infra that we need and all the tooling that we need in addition to their proprietary model? How does Databricks, how do you think about the space? Sorry, I just asked about 14 questions in there, but I see you guys smiling and nodding, so I think it probably gets the wheels turning. I'd be curious to hear your take on how open source changes the game.
Yeah, I mean, look, I think at Databricks we actually have taken an approach where we are agnostic. We will do both. We actually have deals with, actually right now, at this moment, there's a talk going on with Anthropic and Ali that's online. So Anthropic is a strong partner of ours. We're actually going to be partnering with all the major closed providers. Maybe they won't stay that way. OpenAI is releasing an open model soon, they said. So I think what's very clear is that open models and open source are absolutely here to stay. They're a fundamental part of the infrastructure now. There's no real world system that exists out there that's just one of these closed source models. Like George is saying, compound AI systems or agent systems, whatever you want to call it, are a combination of these things. So is it going to be 50% of compute cycles are in open source models, or is it going to be 20%? I don't know. But I can tell you this, it will absolutely have open source components to it. That is 100% certain. So we've taken the approach of, okay, where I want to customize capabilities and I need to tune them, or I need to be able to modify the model, then make it an open source component. Things that I know really well, and I know this closed source model does really well and does it cheaply, use that. Just be practical about it, right? There's no reason to have to take an ideological stance on it. Let's pick the thing that works. And I think we're seeing that approach work quite well. Like actually, we just published a paper, I don't know, about a month ago, where we're able to train a smaller model without labels. And so what you can do is actually put it into production first with a closed source model and just get it up and running. Okay, the costs aren't great. It falls apart on certain use cases. Now I can feed that stuff back in, make a smaller model that's faster and cheaper to serve and more customized. So it becomes this evolution. Maybe I start here and I evolve the system into something else.
Yeah, I wonder if, the small model thing I think is very interesting. And when we start to talk about small models, I wonder, are we just like going back to what we used to call ML, right? A purpose-built model that does something really well. And so I don't know if you guys have a perspective on that, but I think it is critical that obviously we start to move away from the largest pre-trained models exclusively, because there's going to be little models like everywhere, and so that creates a new orchestration challenge and a new integration challenge and all of these things, this fabric that stitches all these things together. So it seems to me like that's the vision of the future, in spite of how good the largest pre-trained proprietary models are. There's still going to be this sort of diaspora of like little models to do effective things efficiently and cheaply that are required.
Well, yeah, so, we saw this actually at Mosaic. It was an analogy we always like to use. The beginning part of my career was in silicon design. So I was a computer architect, I designed chips, all this kind of stuff. And so if you look at the economics of silicon and silicon fabrication, you would have the Intels of the world who captured a lot of share, but they built basically one major product. They built a CPU that was general purpose. It could do like all kinds of stuff, many types of workloads. Moore's Law kept making those CPUs, Moore's Law architectural advances kept making those CPUs better gen on gen. They're expensive to build and they're general purpose. There's one size fits all. Then you had this whole long tail, what we call application specific ICs or ASICs. So, TSMC, which is now the biggest semiconductor manufacturer in the world, actually made their business on how to build these ASICs, right? The long tail. Turned out that long tail ended up being bigger than the one size fits all. But it took many years. This is like a 30-year progression, right? But Intel was famous for having 65% gross margins for 20 years, right?
It's a hugely interesting analogy, right? Because if you think about the foundation models as the big Intels, right? And then you have this entire long tail. And what's really fascinating to see with this particular perturbation in the long tail is like DeepSeek was a really interesting moment, right? Because you started to see, okay, we can take distillation techniques, mixture of experts, being able to look at instruction time tuning and be able to build just a better model that's lighter weight, that's more domain specific. And so that point of seeing that long tail, particularly for domain specific models, it's just here. Like there's just going to be lots of sisters and brothers and cousins of DeepSeek coming just around the transformer itself. But then let's go beyond that, right? Because if you think about what does this small language model look like where you don't need to use it to the transformer architecture, because you can get a micro compact model that can be deployed on the edge. So I invested in a company called Festino, which is literally using an alternative to a transformer, which was focused on semantic themes. And it didn't use a multi-head attention technique to build, the model. And that was able to get to another 100x improvement on inference, just because it didn't know 16th century British history. It happened to just know the topic that it needed to know to answer the question it needed to answer. So there's a lot more vibrancy in this, call it, ecosystem in the long tail. And I don't think it's just around open source. Open source is absolutely here to stay, but there's plenty of opportunity for both closed and open source across the spectrum.
And do you think this explosion of long tail small models, do you think that this shifts the power away from the classic large data infra companies in some way? Do you continue to be a large data infra company where you've sort of always seen data as sort of the gold of the organization? I mean, Databricks is, I guess, the best example of this, because you are that data infra company, and you're embracing the model side and the LLM side aggressively. So you're a special example of this. If you took your Databricks hat off, like where do you think this leaves the rest of the market? Like, is there going to be a segmentation? Do the infra companies have a chance to succeed against sort of if the models are the new platforms?
Well, okay, I mean, of course I'm biased because I'm at Databricks, but I actually think we're in a brilliant spot because we're immune to all these possibilities. Everything you said, you still need Databricks, right? You absolutely need all the data infrastructure, you need governance, you need all the pieces that we bring. So I think all of that puts us in a wonderful spot. But
By the way, that was point number one in my thesis for the memo for when we wrote.
perfect, yeah.
6 months ago or whatever, 3 months ago.
So I think the big cloud guys are still going to be okay because they kind of fall somewhat into that category, and they have embraced enough of the GPU kind of AI compute infra. They all know it's important, and so I don't think it's going to create a dichotomy there. I know that was, I mean, maybe it will. That's been the thesis behind the neo cloud kind of thing, but I do think the big guys have largely caught up. So I think what you'll see is the ones who have embraced basically getting their data infrastructure to a point where you can enable its use in AI. Then I'll give you a great example of that, or like the Epics and Cerners of the world in the healthcare space have not quite done that. And it's really gonna hurt them. There's gonna be some player who comes in who basically manages the data in a way that makes it amenable to be used by AI. Mm-hmm. They're gonna destroy them. Or those guys will adapt. It's one of the two. Mm-hmm. So that's the dichotomy I see, is like, are you on this side of the fence being able to use data for AI or not?
And this probably goes back to one of your opening comments, George, about the need for better tools for managing unstructured data.
Yeah. Back to that.
I think there's also a related point. As much as there's like these large-scale winners, like clearly Databricks is a large-scale winner in this outcome, there's a lot of opportunities for the rest of the ecosystem, or particularly when it comes to infra tooling. Platforms and infra tooling still have a lot of opportunity here. Some of it Databricks will continue to soak up, right? But other things, it's just going to co-evolve quite nicely. I mean, like, weights and biases is a great example of this, right? I mean, both weights and biases and MLflow coexisted in the experiment tracking, parameter tuning, version control market, right? And just happened to have different segments in the market that we took upon.
Well, we use both.
And you use both, that's right.
Yeah.
I forgot about that. You did use both.
We were a big user of weights and biases.
So let's see if I can spur a hot take. Fine-tuning is dead. Agree or disagree?
I've gone back and forth on this. It is definitely not dead. No,
Yeah, I disagree. I agree that it's not dead.
Yeah. I thought it was dead.
Why did you think it was dead?
I just thought that there was just less and less need for those, call it, instruction-tuned, fine-tuned models, and you would just be able to get it done using retrieval augmented generation, context windows. Like, there's just other ways to do it, and the tuning side was just hard, and it was dead wrong. Like we absolutely need tuned models.
But I think you said the right thing. It's too hard.
It was too, yeah.
It still is.
It's got to get easier.
That's right. And I think that's the key thing, is that it comes back to the UI. Like, you have to make it accessible in a way that you don't need to know how, the learning rates need to evolve with, atom optimizers and this and that. Like, that's too hard. It's too hard for most practitioners to be able to use it. So you got to make it simpler, add value quickly with smaller number of knobs.
Another question for Ollie, or Naveen rather, sorry. Are you going to let Snowflake win anything in this market?
Why should we? No, I mean, look, having a competitor makes you better every day of the week, right? I mean, we think about that. And we don't want to lose a deal to Snowflake, but I think that competition just makes us both better and serving our customers better, delivering services cheaper, all of these things. So, I think the consumer does win, or the consumer of these services win. So, I mean, no, our goal is never to lose, but of course we're going to. There's certain things that, they may do better than us, and that's going to drive us to try to improve our products if we see that there's an opportunity there. So, I think right now I think we have the leg up on the AI ML side. It's just the DNA of the company, and that's serving us well right now.
I would just add one comment, which is it does appear that there is a moment for Databricks where it is literally just got sort of a relative advantage to Snowflake, and it is what it is. There's also a lot of coexistence, right? There's a lot of like customers that are using Snowflake and Databricks. I know we don't talk about that as much, but it's still there. But I think Naveed's absolutely right. Like this is a big enough world, and it does seem like there's a structural advantage right now for Databricks.
There was actually it's a little known fact. I don't think. Yeah, it's just not that obvious to most people because now we see Databricks and Snowflake as competitors. In 2018, 2019, Databricks didn't have a data warehouse. The common pattern was use Snowflake as your warehouse and use Databricks as your ETL pipeline. So there are very clear ways to connect them. And so we've continued that. We actually see that in a lot of our customers today. So coexistence is absolutely going to happen.
There's a pretty now famous story about Ali called me in 2019, and he's like, "Hey, I'm thinking about building a data warehouse." And I was like, "Oh, that's absolutely the worst possible idea you can possibly do." I was like dead wrong, of course, but that was the moment that we started to see the emergence of that competition because you started to see Databricks SQL emerge as a real product, and it is now very much a legitimate product that can take on anything else in the space, including
now we have the founders of Iceberg as part of Databricks. So.
Well, it's good to have Frank talk, I think, about tools and the tool ecosystem. Again, like this is what I celebrate about the Data Council community is, we're just not attached to any one vendor. And so it's great to have Databricks people here. It's great to have Snowflake people here, Fivetran on the ETL side. And there's just so many competitors in all these spaces that we've literally hosted at Data Council over the years. And it's, the co-opetition can be fascinating, the partnerships, the strategy shifts. It's been very interesting for me to watch this from a business perspective. But the folks here are literally building, the next generation of infra and tooling systems. So I just wanted to give you a chance, sort of as a closing comment, each of you, if you had to give founders in the room some advice or inspiration around sort of what to think about working on or how to work on it as they approach this nascent AI data infra world, and potentially even thinking about integrating the two. Since you're both infra guys, what would you say to them?
Maybe I'll start because this is going to be more impactful than mine. I'll let you finish on that one. I think there's two areas where I see you can actually make an impact. Don't go copy what someone else is doing. The funding levels are so high for certain companies right now, you're going to lose probably. So there's two areas of innovation. One is really take on a hard problem of correctness or something like that. You're going to have to raise a lot. It's going to be a very hard problem, very uncertain. And you got to have the right DNA of the company, the right founders, all of that. The other one is UI innovation. A lot of this stuff people are delivering as a chatbot. That is shit. It is the worst fucking interface I've ever seen for most applications. I'm so tired of seeing chatbots. Please fix this. Give people the insights, the intelligence to the right user at the right time. This is why IDEs and coding interfaces have taken off, because they deliver value where I need it. They don't make me have to cut and paste something into a chatbot. That is the stupidest interface I've ever seen. So let's fix those interfaces and actually deliver intelligence the right way. And I think there's so many opportunities for people to come out and have creativity here, right? The hard problems are still the hard problems. You can go found that company. But there's so much here that everyone has been focused on the hard problems, and probably too many people have been focused on the hard problems, that we're not seeing this thing, the user interface in front of us.
The 2 points that I was going to make that really dovetail very nicely to what Naveen just said is this notion of and it's how we started this conversation, this notion of a separate stack for data versus the AI systems that are being built is actually a false choice. Because at the end of the day, this is a much more converged system, and it certainly proves itself not only with Databricks' success, but this entire ecosystem that's basically evolved around the modern data stack, right? If you think about where the modern data stack is headed, it is actually headed towards building the next generation of compound AI systems. I think that's sort of important point number one that I really look for in whenever I look at it, call it the next sort of wave of infrastructure investments. The second thing I really think a lot about is most of software is going to get reformatted, if not already starting to get reformatted. And it's because we're starting to see this sort of infusion of compound AI systems into how software is being built. So I think this is going to get way more interesting even than it is today, because the AI portion of what we look at today is not just going to eat up all of software. It's actually going to eat up more than that, right? It's actually going to eat up the services surrounding our software. It's going to eat up the labor pool surrounding our software. So the systems that we're building next, because this sort of convergence around data and AI is needing to happen now, if not already, is going to lead to a whole new class of software emerging. And that's the prize. Like, this is not a data infra story. It's not an AI stack story. It is the future of how we think about all of software and perhaps all of humanity.
Yeah, I couldn't agree more. I think the stakes are very high, and it's going to be very exciting to see what's built in the next 10 years around this new tech. It's changing. It'll change a lot of society.
Absolutely.
I think we have a responsibility to do that in a thoughtful, ethical, sensitive way, which is sometimes talked about and sometimes not talked about. But the tech is really incredible, and I think it's bigger than cloud, it's bigger than mobile, it's bigger than the shifts that we've seen to date, and I think it will permeate through a lot of society. So it's very exciting times. Well, thank you guys for joining us. Really appreciate you being here.
Absolutely.
Thanks, Pete.
Thanks for having us.